Okay, geo means geographical and metri means measurement. Okay, this type of MCQ question you have already seen, Irshad. So if it can be, what is the actual meaning of geometry? Okay, so you should know it means geographical measurement. Okay, now previously these all the things, like these things are written in your chapter in the first page, second page. Okay, history type of, like, so many story is given over here, given over there. So basically that represent that previously in ancient era, when people were not having that much understanding of mathematics, then also they were drawing the figure. Okay, drawing the figure means they were using the shapes. Okay, here you can see for this flood, they have made a boundary. Okay, I'm talking about this boundary, which is somehow, okay, you can see a triangular structure over here. So for this natural calamity, they were using shapes, they were using already, but it was not known to them that the name of this, can you see the orange color part which I am trying to highlight?
Yes, ma'am.
Okay, it was not known to them that here they are drawing triangle. Okay, so this name of the shape, they were not aware about that. Okay, the length, breadth, area, nothing was known to them, but they were using shapes in their day to day life. They were using shapes. Now in the history of Egypt also, we have seen this pyramid. One more thing about pyramid, the base of the pyramid can be any polygon. Okay, the base can be rectangle, base can be square. The I have shown rectangle over here, but it can be square as well. Okay, base can be triangle, base can be any polygon. Okay, pyramid's base can be any polygon. That type of MCQ question also you have seen. Okay, yes, Sara, are you getting it?
Yes, ma'am.
Okay, now here, even if that time they have developed a lot, they were having, now in Egypt, when they started just having the proper understanding of this shape, and this shape's name is pyramid, like few mathematician came. Okay, they started doing the research and all. Then they said that this is pyramid. They were having the proper understanding then about the pyramid, that this is truncated pyramid, that means the broken pyramid. You can see the broken pyramid we are having. Now this truncated pyramids, a volume also they were finding. Okay, they said that since it is a 3D shape, so volume of this particular shape will be the upper parts volume, okay, and the total volume, total pyramid's volume minus upper part volume, that will be the, that will give the volume of the remaining portion, that is this one. Yes or no? Total minus the smaller pyramid, the upper part. Yes or no?
Yes, ma'am.
Okay, total volume minus a smaller volume. So this much understanding they were having at that time. Okay, then in the era of Harappa and Mohenjo-daro, we have seen that how well planned city was there. Okay, building was there, brick was there, where the length, breadth, height was having the proper ratio, 4:2:1. Okay, that much accuracy they were having. Okay, the bath, for bathing, they were having proper space. Okay, proper streets they were having, parallel roads they were having. So it was so much developed. Then suddenly, due to natural calamity, everything, due to the flood or whatever, everything just got destroyed. Right, right. You have learned this all thing in history, right, Irshad and Sarah?
Yes, ma'am.
Okay, and then there, this is Sri Yantram. which we were talking in today's class. Yes, Sarah, if you are thinking that which class, he has joined in another batch as well. So this is Sri Yantram. People used to worship this shape. Okay, Sri Yantram. This contain 9 isosceles triangle. Okay. Now here you can see the first known proof given by Greek mathematician. So most of the time it will come in MCQ question that mathematician Thales was from Egypt, Greek. Okay, few more countries name will be there. So Greek mathematician Thales, he has given circle is bisected by diameter. This theorem for the very first time he has given, okay, a theorem that is based, that is related to circle and given by Greek mathematician Thales. For the very first time, Thales has given a theorem based on circle. Okay, name of the mathematician was Thales. He was from Greek. This much you need to know, because in fill in the blanks question, MCQ question, these type of question definitely will come. Got it?
Yes, ma'am.
Okay. Now Pythagoras was one of the famous pupil of the Thales. Okay, Pythagoras theorem which we use always, that Pythagoras, that mathematician was one of the pupil of Thales. Okay. Now Euclid was also Greek mathematician. Okay. You can see Euclid was also Greek mathematician. So most of the time this type of MCQ question do come, that what, like Euclid was a Greek mathematician, or Egypt, or from where. Okay, so yes, please see this one. Now Euclid has given definition, axiom, postulate. Okay, at first we will be talking about definitions given by Euclid. So there are few definitions. Yeah, okay, these are just few definition given by Euclid. So the first definition says that, as you can see, let's go through it quickly one by one. So the first definition says that a point is that which has no part. So the point which we draw, no, okay, it doesn't have any dimension. Okay, no length is there, no breadth is there. Our point must not be this much thicker. This is incorrect. Logically, this is incorrect. This is not a point. Point means with a very sharp pen, with a very sharp pencil, you will just give a dot, and that's point, which even if anyone want to measure it, will not be able to measure it. That's the point. Are you getting?
Yes,
Okay, so point is that which has no part. That means point doesn't have any dimension. Point has zero dimension. Okay, even if we want to measure it, we must not be able to measure it, but practically, okay, we make it thicker so that it will look like we can see it properly from our eyes. It will be visible to our eyes. That's why we make it thicker and more thicker. But actually, mathematically, point means a very, like a very small dot made with very sharp pencil or pen. Now, the a line is a breathless length. So line is such where we have just length but not breadth. Okay, line has just length, breadth is not there. Okay, now, yes, and line has one dimension. So if you make line like this, a very thick line like this, okay, this is completely incorrect, because line is such where we can, even if we want to measure it, we can only measure the length, not the thickness. Thickness will not be able to measure over here. That's accurately, that's line. Okay, it has one dimension, that is only length. So far, is it clear?
yes, ma'am.
Okay, now the end of a line at point. We can see end of a line are nothing but just point. So you can see this says that the end of line are point, and the next one says that a straight line is a line in which point are evenly distributed. So basically Euclid said that end of a line are point, and basically line is made up of so many point combined together, attached together. Read it. A straight line is such a line, is a line, it is written, that means is such a line which lies evenly with the point on itself. That means so many points are evenly lying on a line. Getting it?
Yes, ma'am.
Okay, line is made up of point. The end point of line, okay, are the end of line are point. Okay, now the next one, a surface is that which has length and breadth. Surface is that which has length and breadth. Okay, we can talk about rectangular surface, we can talk about a square surface, we can talk about triangular surface. So basically surface is that which has length and breadth, 2D shape. Okay, two dimension we are having. Okay, now next Euclid said that the edge of surface are line. Okay, surface is not made up of lines, so many lines attached together, so many lines attached together, and that has given us a surface. Okay, so you can see surface is that which has length and breadth. First it says that surface has two dimension. Then in this definition, the orange color highlighted one, it says that surface edge are lines. So we can see, yes, edges are lines. Okay, and the next one says that a plane surface is a surface which lie evenly with a straight line on itself. So many straight lines, okay, attached together and made a surface. Got it?
Yes, ma'am. Yes, ma'am.
Okay, now these all. So basically I'm combining all of it. So basically Euclid says that you can see from the downward direction. Okay, from the bottom I'm explaining it. So at first Euclid said that it, yeah, at first Euclid said that point has no dimension, that means zero dimension. Now so many points taken together will take a shape of line. Okay, and then so many lines attached together will give us a surface. Okay, and then so many surfaces attached together will give us solid, that means 3D shape, right? So zero dimension is getting converted to one dimension. Okay, so point, if you will combine them, it will take a shape of line or curve. Line or curve is the same thing. Okay, line or curve is the same thing. Okay, the definition of curve is such a line which you can draw without lifting the pen. So this one can be drawn without lifting the pen, or maybe this one can be drawn without lifting the pen. This is also curve, this is also curve. Okay, so straight line is a curve itself. Okay,
Okay, ma'am.
yes Sarah, any confusion?
No, ma'am.
So point just combined together given us line, line combined together 1D, line is having one dimension, that is getting converted to surface, that is two dimension. And surfaces, when you will take a rectangular surface, another rectangular surface, you can see we can make a cuboid, we can make a cube, we can make cylinder out of that. So yeah, surfaces attached together is giving us a 3D shape. Okay, so this much, like with the help of the definition. And one more thing, the definition which you can see over here, okay, that much definition we are not having, only this much definition Euclid has not given. Throughout the mathematics, most of the definition in geometry is given by Euclid. Okay, parallel line, perpendicular line, most of the definitions given by Euclid. Here you can see from total 23 definition, few are mentioned over here. Okay, this is statement has been taken from your book. So you can see few definitions are mentioned over here, but there are so many, and parallel line, perpendicular line are among them. Okay, so if this type of MCQ question will come, that parallel line definition is given by Euclid. Euclid has given the definition of parallel line. So this type of MCQ question can be there. Got it?
Yes, ma'am.
Next, axioms. First, you need to learn all this axiom. Okay, one by one, you need to learn all this axiom. Now, first tell me, have you learned the axioms? Irshad and Sarah,
No, ma'am. No,
previously,
ma'am.
have you learned the axioms?
Yes, ma'am.
Yes, Irshad, have you?
Yes, ma'am.
If I will remove this screen and will ask you to tell me the axioms, will you be able to tell me?
Yes, I haven't revised it recently, so I couldn't recall most of it.
Okay. Yes, Irshad, you.
Ma'am, I didn't remember.
Okay, you also need to revise. So these are the axioms. Okay, let me explain it quick. Basically, why these axioms are important. One by one, you have to memorize. Like axiom number one is this, axiom number two is this, axiom number three is this, axiom number four is this. Like this, it must be on your tips. Okay. After learning, like first let me give the brief of the axioms as well. So first axiom, basically these are very obvious. When you will read this axioms, no, you will think that you already know that, what is new in that? But yeah, there is nothing new, because you have learned the practically you have used the concept first, and then you are learning definitions in class 9. From class 1 to 8, whatever you have learned, these are just the contribution of these mathematicians only. In maths, whatever you have learned, like these mathematician Pythagoras, Thales, Euclids, they have given all the concept which we use on daily basis, while adding, while subtracting, while taking any shape in geometry given by Euclid. So many things. Parallel line, we know that distance between two parallel line will always be same, and parallel line will never intersect each other. You know that. Okay, but when these things you were learning, that time it was not known to you that these are given by Euclid. That time you were not having that much of understanding, so that you can go through all this history and all the history of mathematics. Okay, so at first you have learned everything, and now you are seeing that okay, Euclid was given everything. Okay, that's why when you will read this statement, the axioms, it will seems to you so obvious. Okay, it is obvious. Things which are equal to same thing are equal to one another. Okay, things like uh we can say that AB, okay, and CD, we can say AB is 5 centimeter, and CD is also 5 centimeter. Things which are equal to same thing, AB is 5 centimeter and CD is also 5 centimeter, then we can say that AB is equals to CD, right?
Yes, ma'am. Yes, ma'am.
Okay? Things which are equal to the same thing are equal to one another. That's what is written in this axiom number 1. Okay, next axiom is, if equal are added to equal, the whole are equal. Okay, if equal, suppose example AB is equals to CD, equal, AB and CD are equal. Okay, and we are adding same on both side. Suppose PQ is equals to ST. So suppose AB and CD, which was equal to each other, you are going to add same thing on both side. So here you will be adding something, and the same thing you will be adding on the other side. then whatever result you are having over here, that result will also be equal. Here equality sign is valid. Okay, so in this box I am going to drop PQ and I am going to drop ST, and I am going to say that yes, we have added these two boxes are same. Are you agreeing with me that these two boxes are same?
Yes, ma'am.
Sarah, AB and CD already equal, we were having, and we have added same box on both side. In one of the box PQ is there, in another box ST is there, and I am telling you both boxes are same. Is it same? Of course it is same. Yes or no? To our eyes it is not looking good. No, no, it is not same, but it is same, right?
Yes, ma'am.
Getting it, Sarah?
Yes, ma'am.
Okay, so that's the meaning. This is how we will be using this axiom while doing the proof. Okay, that if equal are added to equal, the wholes are equal. We have two things which was already equal and we are adding same thing on both sides. Same doesn't mean that x you are adding here, x you are adding there. To like it will like it will be same like x and x. To our eyes also it will be like we can see it's like the same term, you will be able to see it. That's why that's what I am trying to say. It is not the case that always, okay, you will be able to see that 5 centimeter you are adding over here and same 5 you are adding over here. Okay, that way it will be, of course it will be like this axiom number 2 will be applicable, that if x is equals to y, if you are adding 5 here, you are adding 5 here, then x plus 5 and y plus 5 will be equal with each other. That you are understanding, but understand it this way as well, that if AB and CD are equal, then you are adding PQ to one side, ST to another side, and it's still both are equal. Okay, because PQ and ST was already same with each other. Got it? Got it?
Yes,
And
ma'am.
okay, the next one, if equal are subtracted. So instead of adding over here, you could have subtracted over here. You could have subtracted this PQ from here. You could have subtracted this ST from here. And still your equality sign is valid. Okay. You are not disturbing the equality sign. So you AB and CD was already equal and you are subtracting same thing from both sides. Your same thing are PQ and ST. Okay. Now the next one, things which coincide with one another are equal to one another. The best example of this one is, can you see two lines over here?
Yes, ma'am.
If both the line will coincide with each other. Okay, if you will place like this and both are just covering each other completely. Okay, I need to stretch it. If both the lines are covering each other completely, that means coinciding with each other, then both are same. Can we say that?
Yes, ma'am.
That's the meaning of coinciding. Okay, if one triangle you are taking and another triangle you are taking, and if both are coinciding with each other, that means covering each other completely. If you are taking one of the triangle over here and you are taking one more triangle over here, okay, You are taking one more triangle over here. And if both are covering each other completely, okay, here it is not covering because I have taken randomly, but if it is covering each other completely, you can see clearly here it will not cover, okay, because both are having the same color. That's why this illusion is happening, but both are not same. So if both will cover each other completely, then only we can say both are equal to each other, same as each other. That's the meaning of things which coincide with one another are equal to one another. Got it?
Yes, ma'am.
Next is the whole is greater than the part. Of course, whole is greater than part. If you will be having whole pizza and I'll be having just a slice of pizza, part of the same pizza, okay, then you are having more than me, right? If x is there and x by 4 is there, which one is bigger? X by 4 is bigger than x, or x is bigger than x by 4? Which sign shall I place over here? Greater than, lesser than, what? Equal to? Yes, Sara and Irshad.
Ma'am, could you repeat again?
If x is there and x by 4 is there, which sign shall I take? This sign or this sign?
Ma'am, the first one.
Is it first one, Sara?
Yes, ma'am.
Yes, of course, the first one. X is whole and other one is part of x. So first one is bigger than the second one. Okay, you can check with any number. Okay, there we are doing the part of that. Okay, 8 is there and 8 by 4 is there, you can understand 8 will be bigger. Okay, suppose we are having a number which is not divisible, then also it will be bigger. You can understand if you will divide 7 by 4, you will be getting 1 point something, which is as 7 is bigger than that, right? Right. So that's the meaning of this statement. Why I have taken this? Because of this. Can you see? Yes
Yes,
or
ma'am.
no? Are you understanding why I have taken this example?
Yes, ma'am.
Okay. Whole is greater than part. Of course, whole is greater than part. Mathematically also we understand it. With about pizza and all it is clear. But with numbers also it is clear, right?
Yes, ma'am.
Next, things which are double of the same thing are equal to one another. Yes. Okay, things which are double of the same thing. If AB is 2 times PQ and CD is also 2 times PQ, then AB and CD are equal, right?
Yes, ma'am.
Similarly, the last one, things which are half of the same thing are equal to one another. Okay, double is same, so half will also be same. So these axioms must be on your tips. Okay, you need to learn it really well. Now, postulate. Okay, axioms definition we have covered. Axioms we have covered. Definition you need to learn. You need to just go through the definitions really well. Okay, you don't have to learn it because the fill in the blanks question will be like this. A point is that which has dash, so you will write no part. So definition you don't have to memorize, you have to understand really well that point has no part. Okay, and all the remaining definition, the edges of a surface are lines. Okay, this way you have to understand definition. Listen to me carefully, I am saying you have to understand definition, you have to learn, you have to memorize axioms, and you have to memorize postulates. Okay,
Yes, ma'am.
because there is only one chapter. okay, like where learning, memorizing part is there. So please do it. Now Euclid's postulate. This there was axiom, there is postulate. Axiom means universal truth. Axiom means universal truth. What does that mean? That means that today I woke up and I saw sun is rising in the east. Again tomorrow I woke up, I can see sun is rising in the east. Again next day I can see sun is rising in the east. Then I'm coming in this class and I am telling Irshad, Sara, do you know sun is rising in the east? Then
Yes,
you being science student, you will say that no, please prove it. So I will say that proof is not required. Go and check it. So next day you both will wake up and you will see, yes, yeah, sun is rising in the east. So where the proof is not required, it is universal truth. When you will see, you will realize that, yeah, it is true. Yes or no?
yes, ma'am.
Okay, that's the meaning of universal truth. Euclid has given axioms, and those are universal truth. That means the proof is not required for such a basic thing. Proof is not required. The Euclid mathematicians has got these things by observation, okay, where proof is not at all needed. These are the axioms which Euclid has got through observation. He has done so many experiments, so many questions, so many, like with so many figures, so many geometrical shape. He has just done the experiment and he found that every time these things are valid, and they have given it as axiom. Proof not required. This terminology axiom, this terminology axiom, this means the first of all, the axiom can be used anywhere in mathematics, because in later on in probability chapter or in another chapter you will see axiom is there, axiomatic approach, axiom, this word is used, okay, which means universal truth. So axiom, this word we can use anywhere in mathematics. Okay, postulate means also universal truth. But this postulate, this word, here also proof is not required. Okay, mathematicians has got these all the things through observation. This postulate, this terminology, especially we use in geometry. Okay, so axiom can be used anywhere. Postulate, specifically in geometry, this terminology is used. Getting it?
Yes, ma'am.
As you know, in our day to day life there are so many things, okay, which we call in another, like with basic, there are phrases, there are terms for that, but in medical science they call it something else. Okay, for example, there are some people like who don't get, like they struggle with the sleep, okay, they are not able to sleep at night properly, but in medical term it is called insomnia. So like that, okay, postulate is a term which we will be using in geometry, axiom is a term which we will be using anywhere in maths. Why I'm explaining it again and again, because again this type of MCQ question can come. Got it?
Yes, ma'am.
Now a straight line may be drawn from any one point to any other point. Okay, basically it means there is at least one straight line. Wait, a straight line may be drawn from one point to any other point. From one point to other point, a straight line can be drawn. From here you can also understand that given 2 point, we can draw. Don't see this sentence, this is there is some part has been erased from here, that's why this is incomplete. So a straight line may be drawn from any one point to any other point. That means given 2 point, we can draw one and only one straight line. If we are having 2 points, we can draw one and only one straight line. And if we are having only 1 point, then so many straight lines can be drawn through it. Getting it,
Yes, ma'am.
Sarah?
Yes, ma'am.
If 1 point will be given, how many straight line you can draw through it? Yes, Sarah. If 1 point, I'm giving you a point A. Okay, through this point A, how many straight line you can draw?
Infinite?
Yeah, infinite. Okay, and Irshad, if I'm giving you 2 point P and Q, how many straight line you can draw?
One.
One and only one. Okay, yeah. Uh, yeah. The next. Okay, the first one, that is the next one. Next statement says the same thing. Previous was just the same. Okay, given two distinct point, there is a unique line that passes through them. Given two distinct point, there is a unique line, that means one and only one line which passes through them. Okay, then the next one. Here the I can see here number wise postulates we don't have over here. Okay, in your book NCRT, number wise postulates are there. Number one postulate is this, number two postulate is this, number three postulate is this. So please, okay, just while learning, check the numbers also properly. Okay. Okay, now the next postulate is, yeah, the next postulate is two distinct line cannot have more than 1 point in common. Okay, two distinct line. When you are having two distinct line, distinct means different. Okay, this distinct means different. Two different lines you are having. Okay, two different line cannot have more than 1 point in common. So two different line will not have one more than 1 point in common. That means if you are having two line, suppose we are having a line AB and we are having a line CD, then the chances are either both line will be parallel with each other or will intersect each other. Intersect means only one time it will intersect, or again and again it will keep on intersecting. Again and again it cannot intersect, right?
Yes,
If I
ma'am.
am giving you a straight line like this, a pane, and the suppose this cover is also a straight line, suppose, so both can intersect at 1 point only, right?
Yes,
Right.
ma'am.
Okay, again and again it cannot intersect because it's a straight line, you cannot bend them, right? If it is
Yes, ma'am.
intersecting over here, I cannot bend it and again make it intersecting. Yes or no?
Yes, ma'am.
Okay, so if you are having two lines, the chances are both will be parallel with each other. That means never ever going to intersect each other, or the chances are both will intersect each other at one and only 1 point. Got it? Got it? Is it clear? The proof is not required.
Yes, ma'am.
Just a second now, let me check whether the this theorem's proof is there in your book or not. If it is there, then it can come in exam as well. It is not there, right? Yes, it's not there. Okay, still I'm giving you the brief. Okay, who knows if it will come, because this is related to the concept. Okay, so let's see. Let me wipe this part. What is written over here? Proof is already written over here. I'm explaining you. So suppose there is a line L and there is a line M. Okay, Irshad and Sarah. Okay,
Ma'am,
yeah.
in exam, will the proof of the theorem will come?
This is the only theorem. Okay, and you understand axiom and postulate. Those are not theorems. Their proof is not required, right?
Yes, ma'am.
So we don't have to prove anything over here in this chapter at least. Okay, only one this theorem is there, which I am showing you the proof. Okay,
Oh, okay, ma'am.
so two distinct line cannot have more than one point in common if we are trying to prove it by using axiom or maybe postulate. In this chapter, whatever question we will solve, we will always try to use axiom or maybe postulate. We will say that Euclid has only said in the axiom, and that's why we are using it. Okay, this is how we will give the reason. So we are saying, suppose there is a line L and there is a line M, right? Now we are going to say, suppose this two line no is intersecting each other at 2 points. At 2 points, it is not possible, you know that, but we are taking it forcefully that suppose it is intersecting each other at 2 point. One of the point of intersection is P, another point of intersection is Q. Okay, okay,
Yes, ma'am.
okay. So we are saying, suppose there are two lines L and M. We understand already that intersecting at 2 point is not possible, but still we are taking this contradiction that suppose they are intersecting each other at 2 point P and Q. So if they are intersecting in P and Q, this point of intersection you can see. If there is a line, there is another line, both are intersecting each other. Suppose this is P, then I can see the first line is passing through P and the second line is also passing through that P. Yes or no?
Yes,
We can say that, right? Sarah, are you getting it?
Yes, ma'am.
Okay, so if both are intersecting each other and this is a point P, this is P, then we can say the first line is passing through P and second line is also passing through P. We can say that. So since here we are saying that both the lines are intersecting each other at 2 point P and Q, so first line is passing through P and Q and the other line also passing through P and Q. Can you see the statement? Is it making sense now?
yes, ma'am.
Okay. Now only we will say, read here. But the previous axiom of Euclid said that if two distinct, okay, it must not be axiom, it must be postulate. Okay. The previous postulate said that, okay, if there is two distinct point, then one and only one line can pass through that. Okay, if there are two distinct point P and Q, then only one line can pass through it. L is passing and M is also passing through this PQ is not possible. Getting it?
Yes, ma'am.
Okay, and we are done with the proof. Hence our assumption is completely baseless and hence the proof. Got it?
Yes, ma'am.
So again I am reminding, there is a line L, there is a line M, both are intersecting each other. Both can intersect at 1 point, but we are saying both are intersecting each other at 2 point P and Q. L is passing through P and Q. M is also passing through P and Q. But now only Euclid said in one of the postulate that through two distinct points P and Q, only one line can pass. Through two distinct points, we can only join them and make one line, not two different lines L and M. Hence, our assumption is completely baseless, and hence the theorem, that is two distinct lines cannot have more than one point in common. Got it?
Yes, ma'am.
So this is the only proof. Okay, chances are it will never come, but who knows if it will come. You will be able to do it, right?
Yes, ma'am.
Next postulate, a terminated line can be produced indefinitely. Terminated means the stop, there is, okay, this much line segment. Okay, terminated line means there is a stoppage on both sides. That's called terminated line. Can be produced means extended. So terminated line can be produced indefinitely. That means you can extend it till infinity from both the direction. Okay.
Ma'am.
A circle, you must be getting that why we are going through this postulate. Either it can come in MCQ question, either it can come in fill in the blanks question, either it can come in true false question, or maybe we need to use it while solving the question, right?
Yes, ma'am.
Okay. A circle can be drawn with any center and any radius. A circle can be drawn with any center and any radius. A circle can be drawn with any center and any radius. Okay. Center, radius, like we can take any center, any radius by ourselves. Okay. And that's what Euclid said, that whenever we want, wherever we want, whatever is the dimension, we can draw a circle. Right?
Yes, ma'am.
All right angle are equal to one another. Okay. This will be the statement, and the option will be, is it a postulate, is it a theorem, is it a axiom, is it a definition? So you will say it's a postulate, right?
Yes.
Now the next one, this one I'll be explaining. If a straight line falling on two straight line make, if a straight line, okay, if a straight line falling on two straight line, if a straight line falling on two straight line like this, okay, a straight line L is falling on P and Q. Are you getting it?
Yes, ma'am.
If a straight line falling on two straight line, okay, makes the interior angle on the same side of it, makes the interior angle on the same side. So these two are interior angle on the same side, or maybe these two are interior angle on the same side, makes interior angle on the same side, taken together. Taken together means added together. If this is x, this is y. Taken together means added together. Okay, let's read it. If a straight line falling on two straight line, L is falling on P and Q, makes interior angle on the same side, interior angle on the same side of transversal. Okay, taken together means added together. Okay, here also taken together means added together. Okay, now let's read it carefully. Can you see? Less than two right angle? Yes or no? Is less than two right angle means 2 into 90 degree. Two right angle means 90 plus 90. Getting it? Getting it? Less than 2 right angle means 180 degree. Less than 2 right angle means less than 180 degree. Are you getting it? If a line is falling on two line, then interior angle on the same side taken together means added together. If that is less than 2 right angle, that means 180 degree. Then let's read. Can you see? Then the two straight line, if produce indefinitely meet on that side, then this two straight line when you will extend, then this two straight line when you will extend indefinitely, infinitely, you will find that both are meeting with each other. When? When interior angle on the same side sum is smaller than 180 degree. Then both line will is going to get both line when you will stretch it, when you will extend it, okay, infinitely, somewhere you will find that both are intersecting each other. Why? Because those interior angle on the same side sum was smaller than 180, because when it is equals to 180, then in parallel line you have learned that when it is equals to 180, then the lines are parallel with each other. Yes or no? Co-interior angle sum is 180, right?
Yes, ma'am.
So in parallel line concept you have learned that, okay, when it is equal to 180, then lines are parallel with each other. When it is smaller than 180, then lines are going to intersect each other. Got it?
Yes, ma'am.
And this is Euclid's fifth postulate, which is really important. Now this one we have to prove. A, B, C are three line. Okay. Prove that AB plus BC is equals to AC. Okay. Read the question. A, B, C are 3 point. Okay, we have to show that AB plus BC is equals to AC. So we will say that AB plus BC, okay, is equals to AC, of course. Why? Because AB plus BC things which coincide with each other. AB plus BC, when you will take, okay, AB length and BC length separately, okay, that is going to cover this AC. Yes or no?
Yes, ma'am.
So I said that the example, the question, when you will read it, will you will feel that it's so basic. Yes, it is true. But please take a pause and think which axiom will support it. So I'm going to say that AB plus BC when taken together, okay, it will cover AC. Okay, this is how we will not write it. We will say just that things which coincide with each other are equal to one another. And hence the proof. Got it?
Yes, ma'am.
Prove that equilateral triangle can be constructed on a given line segment. On a given line segment, we equilateral triangle can be constructed. We have to prove it. Okay, we have to show it. So let's see what can be done over here. A given line segment, a line segment is given over here. Keep that in mind. Okay, a given line segment we are having, and on that equilateral triangle we want to construct by using axiom or maybe postulate. So equilateral triangle, we want, suppose a given line segment is AB. Okay, now keeping the center as a, we will press the needle of the compass at A and we will take the radius as AB. and you will be able to draw a circle like that, right? Because Euclid said wherever you want, whatever be the measurement, you can draw a circle over there, right? Keeping, like, taking any center, any radius, right?
Yes, ma'am.
Now you are going to press the needle of the compass at a B, and again you will be taking BA as a radius. Previously you have taken AB as a radius, and this time you are going to take BA as a radius. AB, BA is the same thing. Okay, so your circle will look like this, right? And again you will see Euclid postulate, any circle can be drawn anywhere by taking any radius, any center, right? So we have drawn. Now this is the point of intersection you have got over here. Here, a point of intersection is there, which you will join with A and you will join with B, and you ended up getting equilateral triangle by using the postulate. Do you know that this AB, this BC, and this AC all are same? Because these are just, can you see it? Can you see it? See carefully. Are you understanding that from A to C is radius of this orange color circle? Yes or no?
Yes, ma'am.
Which is equals to AB, because AB we have taken the radius originally. Okay, and here also you can see, and can you see that this BC is the radius of this purple circle? Yes or no?
Yes, ma'am.
Okay, so we know that AB, BC, CA all are same, and hence we have drawn equilateral triangle by using Euclid's postulate. Got it?
Yes, ma'am.
It is not that visible to me. From your book, you try solving question now. Okay, from NCRT. You will be able to solve questions from there. Okay, got it? Everything.
Yes, ma'am.
Okay, now you just need to solve questions from NCRT. If you will solve it seriously, then let me tell you, tomorrow, if there will be test, you will be able to do all the questions over there. Let me check here if I can take anything. Is it visible to you? No, right?
Ma'am, the
Vis-
words are small.
Let me stretch it. Okay, so you can see the type of question. Even if it is not visible, fine. You can see the type of question over there. Dhyan se, like, just see carefully how the questions we are having. There are fill in the blanks at the top, which says that a point is that which has, we will write no part. Then there is another fill in the blanks. A dash is a breathless length. Okay, so we will write a line is a breathless length. Yes or no?
Yes, ma'am.
Okay, then another fill in the blanks, which you will be able to do. Okay, all this question, just fill in the blanks, straight to false, match the following. Okay, you can see why we were discussing all this axiom, why we were discussing all this postulate, because so that you can solve these questions by yourself. Okay, and apart from these questions, please sit and solve question from NCRT. Okay, these were the, like, explanation of the chapter, the complete chapter. Please solve the question and let me know, are you able to solve it or not? Now Sara and Irshad, you can take your time and tell me, do you want to ask anything else from Euclid geometry? Please check the question, check the book if you want, and let me know. I'm going to activate the assessment meanwhile.
Ma'am, can you some numericals from surface area and volume?
Surface area and volume.
Numericals can you say?
uh, Numerical from surface area and volume, right?
Yes, ma'am.
Okay, do you have specific numericals, Irshad?
No, no.
Have you tried solving question from NCRT?
Yes, ma'am. Exercise 1.1 and exercise 1.3 also.
1.1 you have done, 1.3
3 also.
also.
Yes, ma'am.
Just a second, no, let me open it. Just a second. Yeah, of course, I'll help you solving questions from surface area and volume. Just a second. So here we are having just the surface area of cone and surface area of a sphere, right?
Yes, ma'am.
Yeah, just a second. So cone you have solved all questions, Irshad?
Yes, ma'am.
Okay.
I have trouble in that hemisphere.
You have trouble in
Hemisphere and hemisphere and
hemisphere and sphere. Let me give the brief of that.
okay.
So basically this is a sphere. Okay, sphere means you can take an example of a ball, a football, or any ball. That's a spherical in shape. Now, when we are thinking about a spherical shape, we are thinking that there is a point in the middle. Inside the ball, there is a point in the middle. That must be the center of the sphere. And that point is such point, that is such a point, okay, if you will join it with any point on this sphere, these all the distances will come out as the same, and that's called the radius of the sphere. Now curves of there is only one surface on this sphere, and that's called the curve surface or the total surface. Both are same. Okay, for a sphere, curve surface area and total surface area is same, and that is 4 pi r square, right?
Yes, ma'am.
Now, when you will, the moment you are going to divide it in two spheres or two hemisphere like this, you will realize that now you are having two surfaces. Okay. Now you are having one of the circular surface, this one, and the curve part which came out from the sphere, that is also there, right?
Yes, ma'am.
And due to that, this area will be 2 pi r square, which means just the half of this one. But here also will be, it is nothing but just a circle. Okay, just a circular lid we are having over there. And that area is pi r square. And due square plus pi r square, that is 3 pi r square. Getting it, Irshad, Sarah, you know that?
Yes, ma'am.
Okay. So area of the hemisphere is 3 pi r square. Why it is 3 pi r? See, 3 pi r square is the total surface area. And if curve surface area is ours, it is just 2 pi r square. Right?
Yes, ma'am.
Okay. That curve surface area of hemisphere is 2 pi r square. But the total surface area, that means this 2 pi r square plus pi r square, that means 3 pi r square is the total surface area of the hemisphere. Now if this much understanding we are having, now we can solve questions from sphere. So let me take few questions. Find the surface area of a sphere of radius. If radius is given in the question as 10.5, then we can find surface area of a sphere. For a sphere, the complete ball, there is only one formula, and the formula is 4 pi r square, right?
Yes, ma'am.
We will be substituting r over here, we will be substituting pi over here, that is 22 by 7, and we will be getting the answer, right?
Yes, ma'am.
Now the next one. Find the total surface area of the hemisphere. Total surface area of the hemisphere formula we know, that is 3 pi r square. And if r is given, we can put the value over here, right?
Yes,
Now the
ma'am.
next one. Okay, a hemispherical bit. The radius of a spherical balloon. We are having a balloon or a spherical balloon. Okay, the radius of a spherical balloon increases from 7 centimeter to 14 centimeter. So previously the radius was 7 centimeter, and once we are just filling it with air, it became 14 centimeter. Okay, the radius of a spherical balloon increases from 7 centimeter to 14 centimeter as air has been pumped into it. Find the ratio of surface area of balloon in two cases. So when you have to find the ratio of surface area, then please don't find surface area here, and then find the ratio. No, directly you can find the ratio. The formula will be 4 pi r square, right? There is only one formula for sphere, right, Irshad and Sarah?
Yes, ma'am.
And when we will find the ratio of surface area of first sphere to the surface area of new sphere, S1 by S2, can you see we will be getting 4 pi will cancel out each other, and we will be getting 7 square over here and 14 square over here, which can be cancelled further. Yes or no?
Yes, ma'am.
Got it?
Yes, ma'am.
Let me check which question is the trickiest question over here. The diameter of a moon is approximately, moon is there and earth is there. We know the moon is smaller than earth, right? We know that, right?
Yes, ma'am.
Okay, now the diameter of moon is approximately 1/4 the diameter of earth. So if earth is having diameter d, moon's diameter is 1/4 of that, right?
Yes, ma'am.
Okay, find the ratio of their surface area. So radius, what will be the radius? D is the diameter. So can we say radius will be d by 2?
Yes, ma'am.
And here this is the diameter, this is the diameter of the moon. So can we say radius will be whatever is there at the place of diameter, whatever is there at the place of diameter, that by 2? Can we say that? Yes or no?
Yes, ma'am.
Now that d divided by 4 divided by 2 means d by 4 into 1 by 2. Do you know that, Sarah and Irshad?
Yes, ma'am.
So it will be d by 8. This is the radius of moon. Yes or no?
Yes, ma'am.
Okay, and radius over here is d by 2. Let's use it. Surface area of moon, surface area of earth. We can find the ratio. Formula is, what is the what ratio we have to find? Let me check it. We have to find the ratio of their surface area. First, moon is mentioned in the question. So moon by earth we'll be finding, because at first, okay, you can find earth by moon, moon by earth, no worries. Okay, because specifically nothing is given, just says that find the ratio of their surface area. Surface area of moon will be 4 pi r square. Our r is d by 8. That's a square. Surface area of earth will be 4 pi r square. Our r is d by 2. That is square. 4 pi gone, right? Law of exponent says that if a by b to the power n is there, then that means a to the power n by b to the power n, right? So this will be d square by 16 divided by d square by 4 we will be having, yes or no?
Yes, ma'am.
Now do you know that we can write it by using division sign, that d square by 16 divided by d square by 4, and this division sign can be converted to multiplication, but the next fraction we have to take the reciprocal of that. Do you know this concept, Sara and Irshad?
Yes, ma'am.
So d square gone. Okay, 4 by 16. That means the ratio is 1 by 4. Can you see it?
Yes, ma'am.
Got it?
Yes, ma'am.